Okay, so we're going to explore the meaning of zero and negative exponents, which you already kind of did with the thinking task, okay? We're going to learn the meaning of zero exponents and negative exponents. And then we're going to learn how to evaluate, find the value of zero and negative exponents. So it says, let's investigate the value of powers with a zero exponent by using the exponent law for division. So if you guys had 3 to the 4th divided by 3 to the power of 4, I know we're reaching back like a full week, but what's the rule for dividing powers with the same base?
It's going to divide the exponent.
You don't subtract the exponent. So you keep the base the same and subtract the exponents. 4 minus 4 is 0. Does everyone see that? So we know if we use the rule, we get 3 to the 0. But if we were to expand this instead, and we got our calculator out and actually typed in 3 to the power of 4, what would we get? Someone do it for me. 3 to the power of 4. 81. And that means the bottom would also be 81. And what happens when you divide a number by itself? You get 1. So that means, based on what we just did here, our analysis, 3 to the power of 0 must be 1. Okay? So what it really means when you get an exponent of 0 is you've got the exact same number value on the top as you do on the bottom. Okay? And that's why they divide to give you 1. Okay? So that is why 3 to the 0 is 1. So our rule then is when a base is raised to an exponent of 0, the result is 1. So 2 to the 0 is 1. 127 to the 0 is 1. 15 to the 0 is 1. X to the 0 is 1. Okay, it doesn't matter which base. If you raise it to the exponent of 0, you're going to get 1. Okay? Now, what do you think this would be? We have a positive 1, yes, because we're showing the base in brackets. But what about if I didn't show the base in brackets? What do you think that would be? Negative 1. The negative just hangs out in front. 5 to the 0 is 1. Okay, so watch for those brackets. Okay, bracket shows you what the base is. Okay, so moving on then, we can also investigate the value of powers with negative exponents. Powers with negative exponents, using the exponent law for division again. So if I have 3 to the 3rd divided by 3 to the 4th, the rule from last week for dividing powers with the same base is to keep the base the same, to keep the base 3 and subtract the exponents. Now your brain is going to look at that 3 and 4 and go 1, but what is actually 3 subtract 4? Molly? Negative 1. Okay? So if we just use the exponent rule, we get 3 to the negative 1. But if we look at it a different way, we can look at this as 3 to the power of 3. What would happen if you did that on your calculator? $27. And what would happen if you did 3 to the power of 4 on your calculator? Yeah, 81. And then if I put this in lowest terms, so I know 3 to the 3rd is going to go into 3 to the 4th, so it might take you a couple steps, but you can actually divide top and bottom by 27, and you're going to get 1 over 3. Because 27 divided by 27 is 1. 81 divided by 27 is 3. Okay? another way to show it is 3 to the 3 is actually 3 times 3 times 3. And 3 to the 4 is actually 3 times 3 times 3 times 3. And you can divide out those 3's, and those 3's, leaving me with 1 on top, not nothing, and 3 on the bottom. So there's 3 ways to get to the answer. But what it's telling us is that 3 to the negative 1 is equal to 1/3. They're equal. 3 to the negative 1 is equal to 1/3. Okay? Okay, so this is going to be, can we repeat this type of thinking? Explain why 2 to the power of negative 3 is 1 over 2/3. Set up a quotient to show y. Set up another quotient to show y. So in other words, you want to make up a question here where the answer ends up being 2 to the negative 3. So give me something that could be on the top, and then if that's on the top, what would have to be on the bottom? Yep. 2 to the 6 over 2 to the 9. Love it. Okay? So she just picked 2 numbers that were 3 apart and put the bigger one on the bottom. Okay? So when she uses the dividing powers with the same base, she kept the base 2. 6 minus 9 is negative 3. Okay? 2 to the negative 3. And then another one that would also work. Another one that would also work. She did 2 to the 6 over 2 to the 9. So pick 2 numbers that are 3 apart. Put the smaller exponent on the top and the bigger exponent on the bottom. And think of 2 others that'll work. Josh, tell me 2 numbers that are 3 apart. Other than 6 and 9. If 5 is one of them, what could the other one be? 8. Okay, so we'll put the bigger one on the bottom and the smaller one on the top. So we keep the base 2, subtract 5 minus 8 is negative 3. Okay, so that could also give us 2 to the negative 3. But it says we want to know why is it 1 over 2 to the positive 3. So we've got to the 2 to the negative 3 part, but we haven't shown why it's the same as 1 over 2 to the positive 3. So we can take either of these guys to show that. I'll take Josh's here. So 2 times 2 times 2 times 2 times 2 on the top, and then 8 times on the bottom. One, 2, 3, 4, 5, 6, 7, 8. So what happens when we divide out each 2 on the top with 1 on the bottom? Those ones divide out. 2 divided by 2 is 1. 2 divided by 2 is 1. 2 divided by 2 is 1. So I'm left with all these 1s on the top, which just multiply to give me 1. And 2 times 2 times 2 on the bottom. But what's another nicer way of writing 2 times 2 times 2? How can I write 2 times 2 times 2 with an exponent? 2 to the power of 3. Okay? So again, 2 to the negative 3, we just shown is equal to 1 over 2 to the positive 3. Okay? Okay, let's just do one here, we won't set up another quotient for time's sake here, but one that would show that 5 to the negative 2 is 1 over 25. So I want something that when I simplify it, it's going to give me 5 to the negative 2. Using the division rule for powers with the same base. We need a base of 5 in the top and the bottom, and two integers that are, whole numbers that are 2 apart. 1 and 3. So I'll put 1 on the top and 3 on the bottom. Love it. Okay, so 1 minus 3 is the negative 2. Perfect. Okay. Now, how do I show that that's equal to 1 over 25? Well, Josh picked nice and easy ones for us, so I just have a 5 on top and 5 times 5 times 5 on the bottom. Because 5 to the power of 3 is 5 times 5 times 5. 1 on top. 5 times 5 can be written as 5 to the power of 2. So that and that are equal. All right, once you get the rule, it's not hard to use, okay? So if we're getting frustrated there, once you get the rule is easy to use, okay? You just need to know the rule and use your calculator, and you can get it. So the rule is, when you raise a base to a negative exponent, it's 1 over that base to the positive exponent. And what it means is, when a base is raised to a negative exponent, what happens is that negative exponent is telling you, it's indicating to you that the base actually belongs in the denominator. Okay? Base actually belongs in the denominator. So see what happened here? When we had 5 to the negative 2, it was actually 1 over 5 to the positive 2. Okay? You move the base to the denominator and you have the positive exponent. 2 to the negative 3 is actually 1 over 2 to the positive 3. Base moves down to the denominator, positive exponent. Okay? All right, so let's try simplify using an exponent rule and then evaluate. Leave, that should be your answer as a fraction. Oops. Eraser. Leave your answer as a fraction where appropriate. So we'll start with an easy one. 7 to the power of 0. What do we say? Anything to the power of 0 is? 1. Perfect. 7 to the power of negative 1. So what's our negative exponent rule? 1 over 7 to the positive 1. Okay? You have a base to a negative exponent. It's 1 over the same base to the positive exponent. And 7 to the 1 is just 7. So that's just 1 7. 7 to the negative 2. So that negative exponent is indicating to you that the base belongs in the denominator. So 1 over 7 to the positive 2. Now that's our simplify step. Oops. So this would be our simplify step. And then our evaluate step would be where we figure out 7 to the power of 2 is 49. And that's our answer, 1 over 49. So this is simplified using an exponent rule. And this is our evaluate. Okay. Hopefully you're starting to get to a pattern in your mind. 7 to the power of negative 3. 7 to the power of negative 3. Ethan?
Also, we said 1/7 to the power of 3,
Yes, which would be
1/200.
perfect. Okay. All right, guys, try the next row all by yourself. I'm going to pause it.
I think I got it
I
right.
know, I think you did. Okay, 3 to the 0.
1.
Yes, 3 to the negative 2.
I got 1/3 to the power.
Perfect, which gives you
1/9.
perfect. Yes, you may go. All right, who's got the next one for me? Charlie?
1
Yeah.
over to the 7 over 2/7. Or no,
Go
let's go
down.
above that.
Yeah.
4/3.
Yeah.
And then next step is 1, and then 1, 4 times 3.
4 to the power of 3.
Yeah, 4 times 3 power.
Perfect. Okay, good things they've got the last one here. Ethan.
So it's 1/5 to the power of 4.
Perfect.
5 equals 1/6.
Awesome. Way to go. All right. Evaluate the following powers by applying the exponent rules for negative exponents. So this is where the negative signs and the bases come to haunt you a bit here, but it says alert. Is the base positive or negative? So if the base is negative, it moves to the bottom. If the base is not negative, the negative sign stays on the top. Okay? So here, is the base negative? So the first step would be 1 over -2 to the positive 3. Okay? So the whole base moves to the bottom, so negative exponent indicates the base moves to the bottom. Now I have to figure out what -2 times -2 times -2 is. Yep, -8. So 1 over -8, or you can put that negative anywhere, so you might put it with the top, or the answers at the back might put it with the top, but that's how you got the answer. Okay, perfect. All right, what's the base for this one? There's no bracket, so what does that exponent apply to? There's no brackets, the base is just the number that comes right before the exponent, so the base is only the 5 here. So that means you're going to leave the negative sign on top with your 1, and you're going to move the 5 to the 4th to the bottom. Okay? Your base is positive 5 because the negative is not in brackets. So leave the negative sign on top with the 1, and then figure out 5 to the 4th, which is 625. Okay, is the base, what's the base in for C? Base? -6, it's got brackets. So our first step's going to be 1 over bracket -6 to the power of 2. Which is 1 over, and then you do -6 times -6, which is, Ethan? 36. What's the base for D? No brackets again, so the base is 7. So we leave the negative on top with the 1, 7 to the positive 1 in the bottom, which is just -17. Okay, so that alert there is really important. If there's brackets, that's telling you what the base is. If there isn't brackets, then it's just a number right before the exponent that is the base. Okay, so our next example, we have Christina and Michelle. They're working on the following check your understanding question, and it's a multiple choice question. The value of 6 to the -1 is, and you've got these 4 choices here. Christina thinks the answer is C, so Christina thinks it's this. Michelle thinks the answer is A. Which one of them is correct? Or is either of them correct? And how do you know? So if I was doing a question like this, I would figure out myself. I wouldn't look at any of the answers. I'd figure out myself what 6 to the negative 1 was. So I use my negative exponent rule. So 1 over 6 to the positive 1, which is the same as 1 over 6, which means Christina is correct. Okay, and we showed why because we showed our own solution. Okay? Now, the students that learn this in grade 10 can tell you this is one of the most common mistakes, okay? Because your brain connects 6 and negative 1 and makes negative 6. It just does that automatically. You have to stop yourself and analyze the question. The negative 1 is an exponent. You're not multiplying by negative 1. Okay, so this is a common error, but not correct. Okay? Everybody good there? All right, our last page here is x is 12. Find the value of x to the negative 2. Okay, so this is what Abby did first. Everyone see what she did? She substituted x with 12. Okay? So it says if x is 12, find the value of x to the negative 2. So she replaces this x here with 12. Now we know what to do with 12 to the negative 2. It means 1 over 12 to the positive 2, which means 1 over, we're finding the value of it. So I need to know what 12 times 12 is. Yeah, 144. Okay. The next one, which is going to be our last one. I'll leave the other one for you to try if you feel confident with it. We're going to use the exponent rules and operations with fractions to show that 2/3 to the negative 2 is 9/4. All right. First step. What do we know? What rule do we know about raising a fraction to a power? Yep. Perfect. That exponent applies to the numerator and the denominator. Love it. That's our first rule we're using. Okay? Now it's going to start to look complicated, but we have done stuff like this. So what do we know about 2 to the negative 2? Well, it means 1 over 2 to the positive 2. So we're going to make a 4-layer fraction here. So this 2 to the negative 2 means 1 over 2 to the positive 2. And 3 to the negative 2 means 1 over 3 to the positive 2. Is everybody with me so far? So we applied the power to the numerator and denominator. Then we said what 2 to the negative 2 was using our negative exponent rule. We said what 3 to the negative 2 was using our negative exponent rule. Now we're going to have to go up here. And now 1 over 2 squared, we can change that to 1 over 4. And 1 over 3 squared, we can change to 1 over 9. And then remembering from our unit on fractions, a fraction over a fraction means divided by. So reaching back a couple weeks, who remembers how to divide fractions? Divide fractions. The rule is the first fraction stays the same. Divide changes to a multiply, and you multiply by the reciprocal of the second one, okay? So you change 1/9 to 9/1. And now you've changed it into a multiplying question, which are the easiest fraction operation. 1 times 9 is 9, 4 times 1 is 4. Okay? So look, we showed that 2/3 to the -2 is equal to 9/4. And that's how many steps it took us. So there's 2 more for you to try. Pick one of them to try. Your tutor can look at it. I'm gonna stop and then go right on to the practice. You got 10 minutes before break?